Section, we're going to learn the definition of reference angles and how to find reference angles, but we will use reference angles in later sections. We'll use them to define the values for the 6 trig functions that we'll learn about later, and we will also use reference angles in problems involving vectors. Not all angles need reference angles. Angles between 0 and 90 degrees, or if you're measuring in radians, between 0 and pi over 2, don't really need reference angles. It is angles that are greater than 90 degrees, or again, if you're measuring in radians, greater than pi over 2, or angles that are negative, in which reference angles are necessary. For any angle greater than 90 degrees, or any negative angle, the reference angle is the angle that your original angle makes with the nearest half of the x-axis. Therefore, the value of a reference angle will be between 0 and 90 degrees, or again, if you're measuring in radians, it'll be between 0 and pi over 2. 202 degrees is greater than 90, and its terminal ray falls in quadrant 3. The reference angle for 202 degrees is 22 degrees. That is because the terminal ray of 202 degrees is 22 degrees away from the negative side of the x-axis. The negative side of the x-axis is the nearest x-axis to that terminal ray. Notice I can arrive at 22 degrees by realizing that 202 minus a half circle of 180 equals 22 degrees. So again, the reference angle for 202 degrees is 22 degrees because that is the angle that the terminal ray makes with the nearest x-axis. Let us look at another example and determine how far the terminal ray is for an angle that is greater than 90 to the nearest x-axis. Here we have 134 degrees. The terminal ray falls in quadrant 2. The reference angle for 134 degrees is 46 degrees. That is because the terminal ray of 134 degrees is 46 degrees away from the nearest x-axis, the negative side of the x-axis in this case. Notice we can arrive at the 46 degrees by taking a half circle of 180 and subtracting the 134. That's going to give us the gap that falls between the negative side of the x-axis and the terminal ray of my 134 degree angle. The idea of reference angles holds the same if you're measuring in radians. Here we have an example of an angle that is 5 radians. Remember, 1 radian is the angle such that the arc length along the circle is the same as the radius of the circle. And 1 radian is about 57 degrees, a little bit more than 57 degrees. So 5 radians falls in quadrant 4. The reference angle for 5 radians is 1.283 radians. Notice that the terminal ray of 5 radians is 1.283 approximately radians away from the positive side of the x-axis. We can arrive at the value of 1.283 radians by taking a full circle of 2 pi radians and subtracting 5. That gives us the gap between completing a full circle and measuring up to 5 radians. So the positive side of the x-axis is the nearest x-axis to the terminal ray of 5 radians, and it's about 1.283 radians away from completing that full circle. So its reference angle for 5 radians is 1.283 radians. Here is another example in which our terminal ray falls in quadrant 4. Here we have 283 degrees. And I can see that there's a gap between that terminal ray and the positive side of the x-axis. The reference angle is going to be the size of that gap. And the reference angle is 77 degrees because a full circle of 360 degrees minus 283 degrees leaves a gap of 77 degrees. and that is how far the terminal ray of 283 degrees is from the nearest x-axis. Now let's consider some negative angles. Here I've rotated clockwise, hence backwards, to negative 77 degrees. And the reference angle, no surprise, for negative 77 degrees is 77 degrees. The gap between the nearest x-axis and the terminal ray of negative 77 degrees is an angular gap of 77 degrees. So the reference angle for negative 77 degrees is positive 77 degrees. Again, the idea remains the same if I'm measuring in radians. Radians is just another unit with which to measure angles. So if I rotate clockwise, hence backwards, to negative pi over 6, for negative pi over 6, the terminal ray lands again in quadrant 4, and so the reference angle is pi over 6, because pi over 6 is the size of the angle between the terminal ray and the nearest x-axis. So if I rotate backwards into quadrant 4 to negative pi over 6, its reference angle will be positive pi over 6 radians. Notice the angles are negative when you rotate clockwise because you're going through the quadrants in reverse order. I'm first going through quadrant 4, then through quadrant 3, then through quadrant 2, then through quadrant 1, versus if we rotate counterclockwise, we count through the quadrants in the normal order. First 1, then 2, then 3, then 4. Consider an example in which the angle is more than a full rotation. For example, 643 degrees. 643 degrees is a full 360 degree rotation plus 283 degrees more. So the terminal side of the angle lands in quadrant 4 like 283 degrees does. But we rotated all the way around a full circle and then kept going and rotated an additional 283 degrees. The reference angle is still 77 degrees because that terminal ray lands 77 degrees away from the nearest x-axis. 643 degrees minus the full rotation left us with 283 degrees. And if you take 360 minus 283, you get that gap of 77 degrees. So the terminal ray of 643 degrees is 77 degrees away from the nearest x-axis. So its reference angle is also 77 degrees. How about if we rotate clockwise or backwards more than a full rotation? And this time let's work in radians. So negative 9.0757 radians would be such an example. The reference angle for negative 9.0757 radians is approximately 0.3491 radians. If I rotate clockwise, one full rotation, that's 2 pi. So 9.0757 minus 2 pi is about 2.7925 radians more. And so if I take a half circle, pi minus the leftover 2.79251, I get a gap of 0.3491 radians. So again, that angle lands approximately 20 degrees away from the negative side of the x-axis. 20 degrees is approximately 0.3491 radians. So the reference angle for negative 9.0757 radians is approximately 0.3491 radians. And again, you're measuring the angular gap between your terminal ray and the nearest x-axis. In this case, the negative side of the x-axis would be nearest. The background of this slide is gray because angles that fall on the axes themselves are angles between 0 and 90 degrees, or again, if you're measuring in radians, between 0 and pi over 2, do not really need reference angles. If somebody wishes to define reference angles for 270 degrees or 180 degrees, they can. There's nothing really mathematically wrong about it. It's just, it's unnecessary, so it's kind of a gray area. If somebody doesn't want to define reference angles for the axes themselves, that's understandable too. The reason why is because we are considering reference angles when we're going to be finding values of the trig functions. And the values of the trig functions are going to be related to the x and y coordinates as you rotate around the circle. The coordinates are going to be obvious if you're on the axes. For example, if I'm at 90 degrees, the point at the top of this circle, if the circle has a radius of 1, is 0 for x, 1 for y, because I'm on the y-axis, so x is obviously 0, and if the radius of the circle is 1, then the top of the circle has a y-coordinate of 1. I don't really need to do any extra thinking to come up with those two values. Same thing at 180 degrees. If I'm at 180 degrees and I'm on this circle whose radius is 1, the x coordinate of the point at 180 degrees is obviously -1, and the y coordinate is obviously 0 because I'm on the x-axis, so y is 0. So there's no really hard thinking that needs to be done. At 270 degrees, I'm at the bottom of this circle whose radius is 1. And so at the bottom of that circle, the x coordinate is obviously 0. I'm on the y-axis, x is 0. And the y coordinate would be -1 because the radius of the circle is 1 and I'm down below where y is 0. If I've rotated all the way around to 360 degrees, somebody could say that 360 degrees has a reference angle of 0. That would be true, but the point on the circle is obviously 1 for x, 0 for y, because I'm on the x-axis, y is 0, and if the radius is 1, I've just moved out exactly 1 space. If you're working with vector problems and a vector happens to point straight up the y-axis, again, that's going to be a very obvious situation. So it's really not necessary to refer 90 degrees or 270 degrees to some other angle. It's going to be kind of obvious from the picture what your coordinates are. And if you're in between 0 and 90 degrees or 0 and pi over 2, then your reference angle is just itself. So again, if somebody wants to say that 44 degrees has reference angle 44 degrees, that's perfectly fine if they want to say that. There's nothing really wrong about saying it. But if somebody else wants to say, well, it's kind of unnecessary to say that 44 degrees is its own reference angle, I would understand that also. So if angles fall on the axes themselves, or in between 0 and 90, or 0 and pi over 2, I generally kind of just leave it a gray area. I don't think it's necessary to define reference angles. Instead, I think it's important for you to picture where the terminal ray is landing and what the coordinates would be for the point on the unit circle or for a vector.